Welcome to today's panel discussion on the topic of machine vision and automated conveyance in greenhouse production. My name is Rob Eddy, and I'm the Resource Efficiency Horticulturalist for the Resource Innovation Institute. Joining me today as the technology wizard behind the curtain is Brenna McMillan, Marketing and Membership Coordinator for RII. We're glad to have you join us for this much anticipated discussion. First, some context. Last September, in a podcast interview, Matt Lingard, Senior Vice President of Agriculture and Science at Bright Farms, provided useful insight on the misconception that greenhouses automate to reduce their workforce. Quote, in 15 years of working with automation, whether it's mechanical or digital, I've never let someone go because we automated something. We simply made it so people can focus more on the things that people are really good at, while machines do what they are good at. Machines are great at repeated, predictable tasks, while people are better at problem solving and creativity. Unquote. Likewise, Marcel Boonkamp, Director of Growing at Green Circle Growers, stated in a 2024 interview with RII, we've never reduced our labor force because we invested in automation. Automation enables you to grow. Without automation, we wouldn't be able to grow as fast as we have. Would you have more employees without automation? Yes, but then also no, because we wouldn't be this big, end quote. The fact is the CEA industry doesn't have enough employees, not too many. A colleague of mine who runs a 20-acre greenhouse tells me that every day he is short almost 100 employees. If CEA is to scale up, to uphold the promise of safer food, local food, tastier food all year round, and food that doesn't pollute the environment, greenhouse automation and new data tools, including machine vision, are going to need to be adopted. Last month, RII conducted a webinar focused solely on controls and automation solutions for small growers. Today's webinar will lean the other way. And I'm hoping that with the help of my expert panel, we'll clear up more misconceptions about these tools. Misconceptions such as that automation is all about quantity over quality, and that automation is not resource efficient. Sharing their expertise with us today are Kane Hogan of Adept Ag, whose U.S. headquarters are in Oberlin, Ohio, and Brandon Waghorn of SEF, headquartered in Leamington, Ontario. Thank you both for being here, guys.
Yeah, thanks for having us.
You bet.
Thanks.
I think the audience knows me well enough now that they don't want to hear or need to hear me talk about my background. So let's jump into this. Kane, would you mind introducing yourself and Adept Ag to our audience?
Yeah, sure. So Kane Hogan. So I've been in the horticulture CA space for about 14 years. I actually am originating from the agronomics team. So I've throughout my kind of background, I've done a number of different jobs. I started field service. I've done controls engineering, and and through different sorts of levels, through designing automation systems, bringing in different techniques from Europe, and in doing software integration with those teams. So a whole different interesting technologies that I've dealt with over the years. Currently, I hold the title of Director of Engineering for our Automation Solutions division at Adept Ag. And the reason I think now it's Adept Ag. So Adept Ag is a little new to most folks. Adept Ag was created in January of 2022. And it's a unifying of multiple companies. So those multiple companies is the agronomics team out of Oberlin, Bell Park Horticulture out of British Columbia, Zwart Systems out of Ontario, as well as Plantech. Adept Ag, really kind of what we're focused on is offering fully autonomous or fully automated solutions from end to end for our customers, and bringing in all those different types of, consolidating those companies into one front allows us to offer full solutions for automation, irrigation, electrical systems, environmental controls, And then on top of that, we also have a solutions team. So if there's any kind of gaps there, that we can kind of work through those and find the right solutions to offer for our customers as they either starting a new venture or trying to scale out their current operation.
Great. Thanks, Kane. Brandon, can you introduce yourself, SCS, and if you would, the Center for Horticultural Innovation?
Yeah, definitely. So I'm Brandon Waghorn. I manage our business development, new product development here at SEF. I've been in the industry about 5 years now. The first half in project management, so building complete greenhouse solutions, and then the second half in business development. So SEF, we're based out of Leamington, Ontario. We're a North American greenhouse builder and integrator. Anything from traditional Venlo to propagation facilities and fully autonomous solutions. We also have a research center here in Leamington. We're up to 25 full-time staff currently. We're researching more industry-led research, unconventional crops and unconventional growing methods, seeing if new crops can become part of our traditional crops that are in the retail space. So that's going quite well. We're also doing genome sequencing, disease detection, and a variety of other things for a vast number of industry partners in the research center.
Great. Thanks, Brandon. That research center is music to my ears. I think that's a much needed part of the whole system of improving the industry. The university research is wonderful. It's nice to have industry research at the kind of scale that you're talking about there. So congratulations on that. Here's the agenda for our hour together. Today's webinar is being recorded, okay? And all registrants will receive a copy of the recording and the slide deck. It won't be immediately afterwards. It won't be during. It'll be, give us a day or two. We got a lot going on here, and it's a few things we need to work out to be able to send those effectively to you. But we want you to have that because it's going to be a lot of great information, and we don't want you to miss it. We'd like to thank the USDA for sponsoring our work and for this webinar. Resource Innovation Institute is a nonprofit public-private partnership advancing climate resilience. That's what we do. That means we are not here to sell you anything or endorse anyone's products or technology. RAI provides resource efficiency education, training, verification services, in collaboration with all the sectors of the industry: producers, researchers, governments, utilities, design and construction sector. We benchmark growers' productivity and resource efficiency. We're the ones getting the data on energy, water, emissions, yield. And we do this with our PowerScore platform. Then we publish reports of our findings to the industry while maintaining the anonymity of our clients. Also, we establish working groups to develop best practice guides and provide education and vocational training in several formats based on that information. Here's the guide we just released. We're really excited about this on controls and automation. The guide describes what the controls are for greenhouses and indoor farms and how they work, how they can be integrated to work together to become even more powerful. There's chapters.
Rob, sorry, the slides just aren't being shared. Could you just, refresh that? Thank you.
It work? Are we good?
Not yet, I don't think.
Let me see. Okay. Oh, I must have hit something. Let me go back and share. Thank you, Brenna, for catching that. That's why you're here, to keep me from hitting wrong buttons. Basic. There we go. There. We back? We back in business?
We're back.
All right. Thank you. So there's chapters on temperature, humidity, airflow, chapter on lighting and shading, on irrigation, another one on CO2 enrichment. And it's not just training folks how to install these or how to get optimum yields. The whole point of it is to talk about those things, but the true point is to give suggested strategies, take-home strategies for reducing energy consumption, reducing peak loads, reducing water consumption. There's also chapters on conveyance and machine vision, which is why we're here today. This is a free guide. Brenna will put the link to it from our RII catalog in the chat, so you can open it up. Here's the working group we put together to create that guide of 18 different member companies, organizations, universities. Much like today's webinar, this guide is a blend of industry-informed content with academic research and engineering advancements, providing non-biased information that we believe is unique. Okay, let's get into some of our context here. Let's get down to the machine vision and conveyance. Now that you know who we are and what our purpose is, let's talk about this technology, how these tools are applied. Words won't justify it is the problem. I'm going to show you some videos. These are the best I could find. We've compiled the best we could find into a single video. We'll cover the topics that I'm going to show you in a moment, but you're likely to see more technologies used in synchrony with these technologies. For example, I've got this slide on here to remind you that although we won't see any videos on robotic harvesters, like this one that harvests strawberries, a lot of them use machine vision to help it decide which produce to harvest and where to cut it. So I've highlighted with a little yellow box there where the camera is on this robotic strawberry picker. And on the right is kind of what the machine is seeing. It's finding the berries. You can see the little boxes, little green boxes around it, finding the berries, finding out which ones are ripe, and the ones that are ripe that need to be harvested, it finds out it's looking where to cut it. Okay. While they're doing this, a lot of these robotic harvesters, I'll throw out there, are collecting that data for what's not ripe yet, so that the growers will know what's coming in the following week. So it's got yield prediction algorithms in it. Okay, here is what we're going to take a look at in our video. So what I'm going to do is I'm going to stop sharing this, bring up the video. It's about 6 minutes long, and I'll give you some context during it. Can you see that, Brenna? Are we good?
Yes.
All right, I'm going to go ahead and play it. These are short clips. You can find these on the internet. When you get the slide deck from us in a couple days, you'll have access to these videos, usually the full videos, but I'm going to show you the edited ones. The first one is grading leafy greens. You'll see conveyance, but they also talk about machine vision. I think this was new to me.
When harvest time comes, the plants move along the conveyance system to this big yellow robot arm, which loads the towers into the harvester. As the tower rolls through, blades slice off the greens and they enter the quality control, packaging, and distribution side of things. Quality control happens here with a blue light and a computer vision system that keeps an eye out for any damaged or discolored leaves and uses puffs of air to knock them out of the flow of healthy greens.
Okay, so you saw the conveyance and you heard about the machine vision. It is actually helping find little leaves that don't meet the quality requirements. It's doing a quality assessment, and that's using a puff of air to blow those leaves out of the stream of produce being packaged. So here's another example of it's not just quantity. This machine vision and conveyance is being linked up in that system at Plenty in Compton, California, to improve the quality of the product. Let's keep moving. This will be orchids in pots, and they're being graded to decide if they are ready to ship. If they're not ready to ship, what greenhouse they should go in to improve their growth.
Once the table is full, it will automatically eject the table from the track, push it onto the train, and return it to the greenhouse. All table movement throughout this facility is automated. 12 weeks later, the orchids arrive at the second grading system. Again, the orchids will be graded based on 2 photos, One photo from the top and one photo from the side. After the camera determines the size based on leaf surface area, orchids graded medium or large will move to growing phase 2 for 10 to 13 weeks. Orchids graded small will stay in the current compartment for 6 to 7 additional weeks before being graded again.
I'm going to stop there and mention that when they're graded at this small stage, some of them go into one greenhouse, and the others that are too small go into a different greenhouse with different conditions. So here is a resource efficiency moment where if you had all that, if you had not graded them, or if you tried to grade them by hand, it just wouldn't go as well, wouldn't be as efficient and accurate. Now you have the only plants that need that special greenhouse to boost them along a little bit, maybe it's extra temperature, which would take more energy, right, are the ones that need it. Nothing is being treated in this greenhouse that doesn't need to be there.
About 42 weeks after the orchids are transplanted in the 12-centimeter pot, the plants arrive at the staking line. They are placed on an RFID disc, staked and clipped before heading to the camera to be graded for the last time. Approximately 3 to 4 weeks before shipping, each orchid is individually graded by a camera.
So those plants that you saw spinning, they're on that conveyor belt and they're being spun around. The reason they're being spun is that they're in the imaging booth and the photographs are being taken from all sides of the plant. Next, it's going to show you what the computer is actually doing, which this is pretty cool. This technology, this video is 12 years old, so there's no doubt it's been improved upon since this was made. Here the plant's spinning around. You don't see it for the first couple, but now the computer is picking up where the flowers are. It's counting the number of open flowers, the number of buds, the color of the flowers, the number of flowering stems. All that data is being gathered, and that's what it uses then to determine where to send each of those plants. Since they have RFID labels, they're each individuals, and so it knows, the computer knows exactly where to send that plant. So again, in that one set, that one greenhouse for orchids, you saw conveyance on tables, the table systems, as they call it, that roll along on tracks. You saw conveyance with conveyors where they were picking up and put each pot and putting it on a RFID saucer on that conveyor, which took it to machine vision imaging station. So all the technology you're talking about today is in that one set of videos. Next, let's look at some overhead tracks. This is a way of moving large amounts of plants overhead. And the reason you want to do that is so you don't have to have aisles. So you're increasing your space. And here's another way of doing it. This one is picking up the very same table system tables, sometimes called palletized discs, sometimes called roll-a-bonds, that are used to grow, and just moving it out of the greenhouse, or it could be bringing in a new set into the greenhouse. So here it is moving overhead. Here it is moving it to the end of the greenhouse where it be taken to another location. You can also see pots kind of going down a ramp that's going from one station in the production to another, maybe the grading to a loading, who knows. This is just a short clip of a multi-tier greenhouse. By that, this is really unique to me. It has a greenhouse on top, but it's a multi-story building, and below is I think they probably got service areas and propagation areas. This is for tulips, and so tulips, when they're just planting them, don't need light. And you can see when they're coming out of the lower level and being moved up to the greenhouse level by this elevator, you can see that they're etiolated, meaning they haven't had sunlight. So let's roll this. This is the lower level. So it's essentially an elevator from one level to another. Those are very common in indoor farms that have multi-tiers, but I just want to point that out that it can also be done in that scenario as well. Now we're going to look at it. Now we're going to look at how you image plants where they are. There's two ways of doing this. You can bring the plants to the camera. We've seen a lot of that so far, especially those orchids, or you can take the camera to the plants. And with a lot of our food crops like tomatoes, peppers, they need to stay in place. You can't move those around, right? So there's other types of imaging systems. This one is doing working on some imaging of research plants. It's an overhead camera on a gantry. If you can see my mouse, here's the cameras moving along this gantry and imaging the plants as they move along. So why would you need to do these scans day and night? What they're looking for is they are applying stress to these plants, and then they're seeing which, well, I'll call them cultivars, they're breeding lines, which breeding lines show less stress, whatever it is they're testing, maybe salinity of the soil, maybe drought, and they're looking for the ones that perform the best under those stressful situations, because that's how they'll do their breeding. So it's not just one picture a day. It could 48 pictures a day. They want to see what's happening that often with that granularity. You'll see a little bit of a picture in just a second when I restart it of these plants, these little seedlings growing. And that isn't animation. That's actually the photographs being taken of this, because it has not just RGB cameras to show color and such, but it has LiDAR, so it's getting the architectural features of the plant. Also, it uses multispectral cameras, very fancy stuff, and that has little slices of wavelengths that's taking pictures in. The human eye can't perceive all these, and they can figure out a lot of things based on seeing those little slices of light and different indexes of different scenarios. It's really cool stuff. So here we go. So the reason they didn't show us more of that animation, not animation, but that visualization of plants growing is it's just IP. I mean, they know a lot more than what they're showing you with that, but they just won't put it on their video because they're desperately protecting their IP. Here's the last thing I'm going to show you. Hydroponics can be automated as well. Here's a conveyance of gutters. They call them gullies, and this is in, I believe, New Zealand.
Through constant innovation and ingenuity, holler fresh herbs are being produced more effectively through newly developed technology on site. That technology is moving gully systems. When increasing costs of labour and energy were threatening productivity, holler fresh experts designed these moving gullies to improve on the handling of crops, harvesting and irrigation. Crops are planted and rely on nutrient film technique or media systems to water and feed the herbs constantly on a movable gully. The results speak for themselves. Production has skyrocketed since it was first developed in 2000, with the efficiency in growing area increasing from 55% to 92%. With channels moving to harvesters, there is no damage to crops, and time to harvest and transplant is cut in half. Heating and cooling costs are also reduced by 70%.
So there's three things you heard in rapid succession there. I just want to point them out. You heard that the space utilization increased from 55 to 92%, something like that. That's comparing when they had stationary benches with aisles, that the workers went out and had to walk down the aisles to get to the plants, or the people were going to the plants rather than the plants being brought to them. So there's no aisles in this greenhouse. It's 92%. The second thing you heard was because the plant's being brought to the workers, the way they showed us, it meant that the quality was improved because there was less damage to the plant from the worker having to walk back with a bundle or however it works. So higher quality. And here we have their estimate of heating and cooling savings. That seems kind of extravagant to me. I'm not quite sure what their math was on this, but you can definitely save. You can save heating and cooling costs with this kind of system. So that's the end of our video. Now we're going to jump into our discussion session with Kane and Brandon. I've got some questions that I've queued up for him, and this is a reminder to the audience that you can ask your own questions in the Q&A menu, and we'll try to get to those in the last 10 minutes. Okay. Brandon, I want to start with you first. Let me get this down where I can read it. First, a question I think relevant to both automated conveyance and machine vision and CEA. I'm sure both are easier to adapt if the grower has a single crop, a monocrop, or like say lettuce or orchids, for example. We saw that with the herbs. I guess they had chive at the end, the gullies, they had chives and they had cilantro. Any advice or rules of thumb about the number of crops versus the compatibility of these systems?
Yeah, definitely, Rob. With a single crop, mapping out the processes would be much more straightforward. You can calibrate all of your lines. If you have spacing robots or repotting robots, all of that can be integrated front and back as well. With multiple crops, it'll become more complex. You'll have to generalize sizing of all the machines to the worst case scenarios for both. The life cycles could be different as well as climate and lighting needs. So definitely becomes much more complex. With machine vision, of course, your initial software algorithm will be for one of the crops, but then from that point on, if you have a good software platform that's very user-friendly, some of the newer ones have AI built in to help you do the coding. So you're able to annotate and label very user-friendly without needing a software engineer. So that'll help you to integrate further crops into your machine vision algorithm. So advice, I guess, would be to start with one crop, probably, and then see how that goes, dial in that day-to-day workflow, and then introduce more from that point on. Great point.
Kane, anything to add to that?
Yeah, I think it's especially when you're scaling, give your workers time to grow with the system as well. We've seen it time and time again where customers want to start really fast and it's really intriguing, but have your workers learn the system, get the data, give that feedback to make sure that you are operating optimally, and then gradually bring in your next crop and try to diversify where that is. But you need that training rule of thumb to make sure everybody kind of gets on board and gets used to the automation, and you'll see a much better success in the long run.
Great point. We're not talking today in this webinar about transplanters, seeders, and pot fillers. But of course, conveyance has to feed into all of those things. So it's kind of a part of the systems. And what I've noticed was from watching a lot of these videos is a large operation like floriculture, where there's so many species and so many pot sizes, they'd have to have different seeders and different transplanters for depending on what it was they were producing that day, what size pots or what crops. So it can be tricky. It can really be tricky. I don't know the answer to this. I'll throw this out here I'll start with you, Brandon. How do they decide which crop to start with? Do you start with the crop you're making the most money off of, or are you starting with the crop that has a smaller margin but has a whole lot of hand tasks that the workers have to do? Have you ever come across the growers talking about how they make that decision?
Yeah, you would approach it the one that would be the hardest, most repetitive tasks. Remove that, and then you're able to use the human labor in other areas. So that would probably be, in my opinion, the best approach.
Great, brilliant. I love that. Okay, well, next question, Kane, I want to throw this out to you first. What conveyance might be adaptable to a small grower, like an acre or less? Then as the facility scales, how does the conveyance scale? Does it start with cultivation or seeding and
Yeah.
potting room conveyance, or does it start with post-harvest? If you followed that track, you'd be able to give us any
Yeah, the trends that we generally see is going after labor that's really transferring the crop in and out of the greenhouse. And that could start with table systems, but generally we even go kind of even a step back and we get down to just basic conveyors. And I can even think about making sure that when you're investing into conveyors, one, they're modular and they're mobile, because you're not always touching that section of the greenhouse all the time. So to make that investment that we're going to have conveyors throughout the entire greenhouse doesn't necessarily have to start there. There's definitely conveyor systems that you can break down, move to another section, and deliver your crop in and out of the greenhouse, or if there's a spacing program that has to be done throughout the growth management cycle. And then as things kind of scale up, you can just additionally add more conveyance, or you can start looking into table systems depending on like if you want to do more bulk handling, that's when you would really get into more table style cultivation systems.
Cool. And everyone, I just remind the audience, the table style is the type that runs on the little tracks, not just within the greenhouse. So we're not talking about rolling benches that stay fixed. We're talking about those benches that move on tracks and can go to different areas of the facility. Brandon, do you have any wisdom to share on that?
Yeah, maybe not necessarily with a small grower, but with larger operations that have stationary gutters, you're going to see conveyance starting in post-harvest. Typically, you're going to have packing facility and multiple levels of automation in there as well. So that'll be common to start with a few stations. And as Kane mentioned, just to get your staff trained and up to speed and working in harmony with the machines, and then introducing more and more operations as opportunity arises.
Right. Follow-up, Kane, can growers put in the table systems without there being the motorization? Can they just push them along by hand at first?
Yes. Yeah, so rolling table systems do not necessarily need to be fully automated. If you're just looking for that bulk handling, maybe there is a robot, maybe it's just a human worker that is laying the trays down onto tables or pots. We kind of even saw in some of those videos where in the orchids, they were taking the orchids out and then interacting back into a conveyance system. That all can be manually driven as well. And then when there's the ready for the investment to then go back and automate, again, you want to make sure you're looking into those modular systems that you can just take the tracks you already have. Now we can just slap on the motors, drive, have a driven system to fully automate from there. And then just kind of on top of that, you want to make sure that you're allocating space, that if you're going to start adding in overhead cranes to pick up containers, anything like that, or a train along the side, that's all kind of part of that pre-planning stage that you should be initially looking at before there should be your startup plan. What's my full scale plan potentially look like? And that will definitely help you out throughout the entire planning process.
Thank you. That's great. Brandon, back to you. As I promised, we wanted to talk about resource use efficiency with automated conveyance. There are some benefits, right? For example, a very high space utilization that you can get with these table systems. For one, it means a better light use efficiency because you're not lighting up aisles. So all the photons that you're generating with the electricity are actually, most of them are going towards the plants. Is that true? And is there ones that you also identified? Other ones?
Definitely. So light is one. Labor resources would be more efficient. You're also able to amortize more of your infrastructure across the range. which will increase your growing area, which helps reduce your dollar per square meter. The balance to consider, so that's all great, of course, and definitely means an increase in multiple resource efficiency. The offset to that you have to consider is there's, of course, more upfront capital costs. The business case is a little more difficult, and then maintenance costs can also be a little higher because you're going to need on your maintenance team PLC experts typically, especially if it's motor driven, and people who have sensor experience with photo eyes, proximity sensors, etc. So basically, what you're looking at, if you're looking at a new build or upgrading, is how much more growing space you're going to get, and then comparing that to the cost and seeing if the yield will create a business case that will support it. So that's just another facet to look at here, debating on this.
I appreciate that answer. Not only about the resource use efficiency, but the concerns, the considerations you need to keep in mind for all that. I appreciate that so much. That's why I love these RAI webinars, because people are taking off their company hats and aren't trying to sell stuff. They're educating all of us. So thank you for that. What I wonder, when we saw the video of the gully systems, the hydroponic systems, and they made a claim about big heating and cooling savings. My guess was that claim came from the fact that they improved their space utilization so much, they probably did some sort of calculation that said, well, if we had 55% utilization, now we have 92. If we were going to grow the same amount of plants, we would have had to build another, X number of hectares of greenhouses and then heated them and cooled them. So I'm guessing that's probably how they came up with that calculation. Does that seem like a reasonable guess is where they came up with that?
Yeah, I think so, Rob. We have grants also here in Ontario from utility companies, and they'll kind of go off that. So if you can show extra performance in the same amount of space, where something like automated conveyance would do that, where your yield is now increased per square meter from where it used to be, then that would be considered an efficiency gain, and you could actually get a rebate based off that. So that's probably that sounds fair to me, to that you're using the same amount of heat, so you're burning the same amount of gas in your boiler to heat that space, and you have more yield per square meter coming out of the growing range.
Oh, that's great. And what a great reminder. Before you build, before you upgrade, upscale your facility, talk to your utilities, talk to your local utilities and figure out if they have incentives that'll help offset some of that capital expense for that. Kane, anything to add to that about resource efficiency from automating?
I think one thing just to touch on is that when automation is reducing manual labor, we can make sure our labor is focused on high value tasks. And that what allows you to do is justify the higher cost for an individual that's going to be on staff. Somebody that's looking for a long-term career plan, being able to kind of bring in that local help as well and keep that on staff. And then also kind of develop a career plan for them to what's the next high value task you could be working on. And that kind of makes it interesting for workers, and then maintain, what do you call it? Retaining employees throughout the career, retention, you're correct. Thank you. And that's important, to be really successful, is having that retention, keeping that, building that tribal knowledge of being effective is going to be extremely helpful.
Wonderful answer. I mean, what we want to be doing in the industry is building careers, and that's what you're talking about. That kind of moving, upskilling that employee to that point where they're not just a seasonal employee or a minimum wage employee. They're actually upskilled to the point where they've got most likely a better paying job, and it's one that they can hopefully help take care of their family. And so that's just a great response. Thank you for that. Brandon, tell us some more of the impactful advances of machine vision that you see. Now, I got to be careful here. there's a lot of stuff that you can't talk about because it's either your IP or someone else's, but are there applications that some of us may not be aware of that are possible?
Yeah, definitely. So some of the newer technology applications are including integration with AI. AI is obviously a very trending buzzword. So using advanced neural networks to basically recognize and classify objects in more challenging environments than used to be possible. This is coming around. A lot of companies, you saw in that one video where the plants were spitting to sort of to take all these images. Some companies have multiple cameras set up with an algorithm to create a sort of 3D camera so they can instantaneously create the 3D picture and then feed it back through the algorithm and receive the instruction of what to do with it. So this obviously helps, precision, very useful for small, delicate plants, for planting bulbs or tissue culture and things where you have to be exceptionally delicate. You'd also mention multispectral. So hyperspectral cameras is another technology. It used to be extremely expensive, so very difficult to experiment with and trial with. But now with technological advances, hyperspectral cameras are a lot more affordable. So contrary to like an RGB camera, which is just red, green, and blue, that you can see between 380 and 750 nanometers, a hyperspectral camera will capture 250 to 15,000 nanometers, as well as thermal infrared. So this opens up obviously a ton of new use cases, such as very early disease detection by identifying how the light reflects off how the disease reacts to the plant. You can identify nutrient deficiency. Obviously, quality control is improved. And then yield prediction is another huge one that a lot of companies are working on that they'll be using these new technologies with. In addition to that, robotics is obviously another big point that's being worked on. And a lot of companies have commercial products available. We are also co-developing some of those solutions. So all of these things are very close to being main parts of the greenhouse.
Oh, fantastic. Kane, anything to add? That's very exciting stuff, Brandon.
Yeah, I think the one thing to kind of add is operationally, there's been a lot of traditional sensors to interact with conveyance systems to say, is my product in place? And throughout the years, there are issues with that in the greenhouse where foliage could be leaning on a sensor and you're getting a misread. Where we started into machine vision, we can start using, probability of, is my product in the right spot, to start doing error correction. Oh, my robot goes to pick up, is my product in the right spot, or am I going to crash, or did I have a false flag and I need to fix the I can automatically fix, or I need some kind of manual intervention. And that that operational efficiency is going to be gained from that, to basically be able to fix itself, where traditional sensing through different like photo eyes and different like limit switches, your basic stuff, is definitely going to improve year over year.
Wonderful. We got about 7 minutes before we're going to do our audience Q&A, maybe 6 minutes. I want to spend it on where we're heading, and how that might affect decisions that we're making now. Brandon, I'll start with you. And by the way, this is a question I borrowed from Kyle Barnett of Crop Talk Podcast. I think this is always a great one for opening up discussions. Where are we headed? Where will CEA technology be in 5 years or 10 years, whichever you'd prefer to answer? Not just machine vision, but where are we headed?
I think a couple key technologies that you're seeing a lot of companies partnering. So there'll be a horticulture company and they're partnering with an actual robotics company or a company like that. So robotics and AI is definitely probably the main trending points for technology. There's a lot of them that have a commercial product today, but the business case is not quite there. So as you know, we approach 3 to 5 years from now, and labor will continue to rise, of course, and challenges with labor. These business cases will become more and more attractive, and soon that'll hit a tipping point. And I believe robotics will be a commonplace in greenhouses. Also, AI-based autonomous growing, we're seeing that pick up quite a bit with a lot of successful trials, a lot of AI challenges where they're beating Dutch growers at yield and at dollar values with their challenges. Yield prediction, I think we're going to start seeing that when you're combining where machine vision is today with where their algorithms are from harvesting data. I think that's going to start to become more prevalent. And then, of course, disease and pest detection, which are very, very large issues. I think those are going to get dialed in with the better cameras. You're able to see a little bit closer on the plants, which will help you to detect the appropriate disease or pest. So I think that's kind of what it's going to look like in the next 5 to 10 years. We're going to see much more human and machine interaction and integration, and I think we'll see convenience become more of an aspect of technology.
Very cool. Kane, anything to add?
You cover a lot of it.
Yeah. Great.
No, I definitely believe that, seeing what the AI advancements, the predictive analytics that is coming out of that is just astonishing. And I do believe in the 10-year time, we'll start really focusing on how we do energy management to make such as vertical farming more profitable, and overcome a lot of that, where the way we're doing a lot of our energy management now isn't as cost effective, but there are technologies that are right around the corner that are starting to make that more accessible and drive the cost down.
Yeah, good point. And even without AI, there's been some great research on integrating utility predicted prices in with controls. Rutgers Cornell, it's called day ahead marketing. They did a great model on this, that they're saying that some utilities are now at the point where they can begin to predict what the next day's prices will be on the hour. And then if they share that data, and the control computer is aware of that, then the control computer could be making, in either with AI or not, or maybe just smart algorithms, making decisions about turning on lights, raising the temperature, anything that involves energy, not just based on what the crop is needing at that moment, but on what the price will be. So that I'm hoping that's a part of it. I'm also hoping what's a part of it is that AI could be end up being a big distraction too, because the workers, just like the internet has given us all sorts of distractions, emails, chats, all this, AI will too, especially with AI, what do you call them? Friends, AI. And so will a person be distracted because they've got an earbud in their ear, or they got something on their phone that's a relationship, and what I wonder if those could be used, if the AI chatbots could also be uploaded with training information, so that chatbot, who's their buddy, might be actually helping them during the training along with whatever their supervisor is doing the training. But so I'm just excited about where we can go. There's a heck of a lot of challenges.
Yeah.
So now that we've
augmented reality, it's like having Google glasses and being able to see what is like a spectral imaging camera with Google Glass to be able to see what is my crop doing as that grower walks the greenhouse. It's being able to see that in real time, and that'd be really interesting.
Cool. I want to come back to that. I want to take a couple audience questions. We got 2 of them now. If anybody else has any, please type in the Q&A, or obviously we got some great conversations going on here, so be a part of it. One of the questions from the audience is a simple one. Kip asks, which of the videos highlighted the Dutch tray table system, or what we've been calling table systems. I know you guys will have to remind me. I know when we had the orchids, before the orchids were put on the conveyor belt, they were being moved around on these tables in the greenhouse, big silver colored rectangles that were being moved around by on tracks and motorized. And then the other one that I specifically remember is the overhead crane that went down and picked up the Dutch tray, the tray system table, and moved it overhead. That was another example. Is there anybody think of any others that I don't remember?
Yeah, I think those are the ones, Rob. It's basically an aluminum table. It's got a couple wheels with bearings underneath it, and it runs on a rail track, and then it'll be automated using a motor and some little shark fin pushers typically. But those were there's 2 or 3 of the videos that we saw there.
Are those uniform in size from one manufacturer to next?
They're fully customizable. You
Fully
can,
customizable.
can get
Generally,
almost any
you're-
size that.
Oh, sorry. You're generally specing the table to your crop.
Mhm.
Oh, yeah, that makes sense.
The material you're handling.
And I should explain to the audience that those tables also are ebb and flood benches. So obviously you can't have irrigation pipes hooked up to those tables because they're being moved around, but the tables will slide into place. There'll be irrigation pipes there that'll fill them up and will allow them to drain. The next question is, I'm going to read this slowly. Thinking in context of Rob's question of smaller than an acre in terms of system design, is there a typical greenhouse size where O&M, which must be operations and maintenance of automated systems, is contracted rather than maintaining that with on-site staff? Is it always maintained? Are these advanced conveyance systems always maintained internally, or is there ever any service agreements?
I'll put my sales hat on.
Yeah,
So yeah, so from like our Adept Ag group, there's definitely an aftermarket in sales where there's contract service for maintenance, not necessarily from an operational standpoint, but from maintenance. That's something that's we're heavy involved in IoT systems to give us feedback of our equipment. How is it running? How effective is it being? If we need to do a truck roll out to our customer to make sure we're gaining that efficiency back, or if something's broken, repairing, doing preventative maintenance. A lot of times that does get contracted out. And if workers really, or a grower is really struggling with finding a maintenance staff, and that's definitely something that we can definitely help out with.
I think it's definitely important, that support for sure, like Kane's mentioning, from the company you bought it from, or from a company that can handle it. And then typically your operations, you'll have a product champion internally in your workforce. And as Kane mentioned before, somebody maybe who has a really nice career path and has a technological edge, and maybe he or she is interested in getting into the automated systems. So that's kind of what we'll see typically, is you'll have a product champion who's very adept with the technology, and then a support company or something to that effect for what's called level 2 and above situations.
Excellent. Hey, we got another question. I like how the audience member has stated this. They're asking about prices, but I love it that they're not asking you about dollar amounts, just relative amounts. What's the rough capital expense ramp up for an automated tray system compared to a completely manual benching system? So I'm thinking what he's asking is rolling benches that with fixed legs compared to what we've seen, these tray systems. And he's asking, is it 2x, 5x, 10x, 20x? Just kind of somewhere in that ballpark. He's just trying to get a broad sense of.
Tough.
Say again. It's tough.
Tough question. Yeah. I would say more in the double, triple than the 20x for sure. It obviously depends on you know, how automated it is, what the crop is, how many stations do you have, you know, basically how much capital components are you going to have to install in that area. So yeah, it's a tough one to answer with that.
Those always are, because there's so many variables on it. I can say that I was told by a really informed colleague about the tray systems going from manual to motorized wasn't that much. I was surprised. It seemed like it was only the dollar amount per square foot only like doubled to go from manual. So you could start off with manual, but then to go to the next step wasn't all that much more money. That was kind of a pleasant surprise to me.
Yeah, definitely. You would need motors, sensors, and then an extensive PLC programming. So various panels. You'd need a safety system installed as well, whether that's zoned or through the whole facility. But certainly once you have a lot of if it's already manual, but a lot of the aluminum and steel components are in place, then from there it's definitely simpler and not as expensive to ramp up.
That makes great explanation. Well, let's use this to segue back to the question I wanted to ask for, and thank you for the questions to the audience. Thank you so much. How do we prepare for those changes we talked about in 5 years, 10 years? If you're designing a facility now, is there anything that you should be keeping in mind? And if you're hiring staff or thinking about hiring staff when you scale up, is there some adjustments to your thinking? Kane, why don't you start that one?
Yeah, it's really space allocation. You know, it's finding a partner that you can work with to understand where's our starting point and where are we going to scale through, so that the space requirements that you're going to want to push throughout that planning is going to be there. Like if you're not going to, it's very tough to design around pathways that are heavily established, and now all of a sudden we have to stick automation through there. As far as staffing, it's really, you know, the investment on training and new technologies, being able to attract workers in that are interested in that, and also you're really finding that partner as well to help train the staff. Don't think that you're necessarily on this on your own. There's plenty of partners out there that can get your staff up to speed relatively quickly. Really, and it's really just kind of making sure that you're kind of starting from like a pilot program, and then understanding what my challenges were through that pilot, and then pushing through scale. And it's you know, one of the easier ways to do it, especially if you're new getting into CEA. Working out a lot of the bugs up front is definitely helpful.
Yeah, good point. Great points. I really appreciate that, Kane. Brandon, anything to add to that?
I mean, when we look at 5-10 years and how robotics specifically might change that, we definitely look from a greenhouse building perspective. Does the way we build it change? Do the aisles change? Do the rows change length or width? So I think the design of facilities perhaps will be adjusted in the future. And then another thing we touched on as well is when we talk about reducing the workforce, with a lot of these changes, we're actually upgrading the workforce. So we're taking a role that's typically difficult to fill, and we're now upgrading to a technology role, a robot operator, or something to that effect. So that helps, you know, with sourcing local labor, and with sourcing labor and retaining that labor with these jobs that are a little bit more interesting in the industry.
Right, there's a great place to stop. Want to thank Kane Hogan of Adept Ag and Brandon Waghorn at SCF I couldn't have asked for two better experts for this. I enjoyed it. I hope everyone in the audience learned a lot. For Brendan McMillan, I'm Rob Eddy with RAI. Thank you for joining us today.